Welcome everyone. If you're joining us, it is December 10th and 11th, Thursday, Friday. We're going to continue working on our constant of proportionality unit in our blue packet. So if you can go ahead and locate that. And then also I'm going to ask that you open up to page 21. Now I know your pages aren't numbered, as I've said before, but if you flip through, you will find the page that says lesson 7 at the top, and it talks about wildlife conservationists. So I'm going to give you a second, pause the video, flip through till you find the one that looks like this page. So I'm going to start by reading off the top part. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area, yet a third conservationist counted 216 deer in a 24 square mile area of the forest. Do conservationists need to be worried? So question A says, why does it matter if the deer population is not constant in a certain area of the forest? So for those of you who hunt, you know a little bit about deer population and why it might be important. For those of you who don't, that's okay. You might have some guesses, right? So maybe food supply would be a factor over population. If you've ever driven down the highway, you might have seen some unfortunate accidents that happen with deer, right? And so overpopulation causes them to spread into areas where humans kind of are. And unfortunately, sometimes those car accidents happen. And sometimes damage to land. So I'm sure farmers or anyone who has really nice landscaping would tell you that sometimes deer hooves, or they like to eat things that you grow, could be damaging to your land. So let's take a look and think about, what are the two quantities being compared? That's what I'm always going to ask you, is what are we comparing? And hopefully you were able to identify we're comparing square miles and we're comparing deer. So in our table, our X is going to be square miles, and then our Y is going to be deer, number of deer. Now you might be wondering, how did you know how to put those there, Mrs. Carell? Well, think about, a conservationist is going to be given a certain square mile area to monitor. And even through the use of drones and other cameras like trail cams, they might be able to keep track of the number of deer, singular, in an area. So our first one that we're going to be adding in is that in a 16 square mile area, there were 144 deer. In a 13 square mile area, there's 117. And then in a 24 mile area, there's 216. So all I did was I took that data right out of the problem and added it into our table. Now there's some space. We are going to be using that space. So I hope you're following along with me. The idea of you having this packet and being able to pause this video is that you can follow along at your own pace. So the question says the unit rate of deer per square mile. So deer per mile. And then it's per 1 square mile. So if I take my number of deer, so I'm going to use the number of first input output, 144 over 16. Well, that's not a fact that I have memorized. So I can just see if I can reduce it. 144 over 16. And reduces nicely, it gives me 9. So 9 over 1. So the unit rate of deer per 1 square mile is 9. Well, if my unit rate is 9, what's my COP going to be? You guessed it, 9. And then what's our meaning of our COP? So we're talking about 9 deer per 1 square mile. Or you could have said 1 square mile equals 9 deer. That would have been okay too. As long as you can put the word 9 and deer together and 1 in square mile, that's what I'm looking for. Now remember, our equation is in the form y equals kx, where k is our COP. So what is our COP for this problem? 9. So y equals 9x. Part C says, use the unit rate of deer per square mile to determine how many deer there are for every 207 square miles. So they kind of want you to extend your table here. Or you could use your equation. There's a couple ways to do this. So what I'm thinking is that I'm going to put my number in the table, so 207 square miles. Now, if we found that the COP is 9, that means that we're multiplying by 9 each time to get these numbers. So what should we do with 207 to find out the number of deer? Hopefully you're saying, let's multiply by 9, Mrs. Grow. So 207 times 9. And that gives us 1863. I'll put that back there so you can see it. 1863. 1863. So 1,863 deer. And then part D, now if you had used your equation, by the way, it would look like this. Y equals 9 times 207. That's what substitution would look like. And that would give you the exact same answer. Use the unit rate to determine the number of square miles in which you would find 486 deer. So this time they're giving us the number of deer, which is our Y output. So 486 would go here. And they're asking us to find the number of square miles. So am I going to be multiplying by 9? Well, that only worked if I'm starting with my X and going to the right and working my way through. But now I'm over here and I'm working my way left. So my equation would be 486 equals 9x. I need to find 9 times something is going to give me 486, right? I'm multiplying something by 9. So what's the opposite of multiplying? Dividing. So I'm going to do 486 divided by 9. Let's bring our calculator over. 486 divided by 9. And that gives us 54. So 54, what would be our label? Square miles. You got it. Nice job. All right, how are we feeling about this topic? Pretty good? Okay, so we have time. We're going to do one more question. So if you go to page 22, which is just to the right, so we're just going to shift your paper over to the right. There's another question that we're going to be looking at. And it is about cookies, so I hope you're not hungry right now. So Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. What a crazy guy. He needed 3 cookies for each of the 96 students in 7th grade. Man, that kid's crazy. Unfortunately, he needed the cookies at a school event on the very next day. Brandon and his mother determined they can fit 36 cookies on 2 cookie sheets. Is the number of cookies proportional to the number of sheets used in baking? All right, well, we got a lot of information we got to dissect here, right? And it says, create a table that shows data for the number of sheets. We need to make the total number of cookies. Okay, so they've kind of given us the 2 quantities we're comparing. Some kids will think like students and cookies, but that's not really what they want you to compare here. They want you to compare cookie sheets and cookies, and they kind of they called it out right here. Number of sheets, total number of cookies. So the number of sheets that he uses is going to affect his total cookies that he's able to make. Okay, cookie pans, if you want to call them that, that's what they're talking about. So there's one thing that's kind of important to notice, and that is this rate they give you up here, that for 36 cookies, that there are 2 cookie sheets being used. So that's actually a piece of information we can put in our table, that for every 2 sheets, he's getting 36 cookies. And notice I left some space because I want to put in what 1 is. I want to find the unit rate. So a lot of you might be saying, well, to find the unit rate, I would do 36 divided by 2, and that gives me 18. So there's going to be 18 cookies for 1 sheet. So that means he can fit 18 cookies on 1 tray. That means they're pretty small cookies if you've been cooking in Mrs. Miller's class and you made your snickerdoodles, right? So let's now, if we know that it's timesing by 18, could you fill in maybe what 3 and what 4 would be? So 18 times 3. So this is what it looked like on your calculator. That gives you 54. And then 18 times 4. Notice how I just scrolled over? I didn't have to retype the whole thing. That gives me 72. So I've got all my data filled in there. Now it says the unit rate is, okay, well, what were we multiplying by each time? 18. Well, if the unit rate is 18, what's our COP? 18. Can we see what the meaning of the COP is? Well, we're talking about cookies and sheets. So 18 cookies for every one sheet. Now I wrote it as a fraction this time. You could write it horizontally in words, 18 cookies per one sheet. That would be fine. I just wrote it as a fraction just to show a different representation. Our equation member has to be in the form y equals kx, where k is that COP. So our equation is going to be y equals, what's our COP? We said it was 18. So it's going to be y equals 18x. Okay, now the bottom part's a little tricky, so I'm going to kind of walk you through how to do this. So it says it took 2 hours to bake 8 sheets of cookies. And like I said, there's always more than one way to do this. So if you're thinking about this and you're pausing the video and working through it on your own, that's fine. I'm going to walk you through what I think is kind of probably the most organized way to do this. So it says if he can bake 8 sheets in 2 hours, if he and his mother start baking at 4, when will they finish? All right, well, the first thing we need to know is how many cookies are they baking? So if I come back up here, he needs 3 cookies for each of the 96 students. So what do we need to do to those numbers to find out our total number of cookies? Hopefully you're saying 96 times 3. So if your first step is 96 times 3, that's going to give you 288 what? Cookies, right? Okay, so if I have 288 cookies, I'm going to add that into my table. And I want to figure out how many sheets that's going to be. So how would I do that? Well, I need to figure out what number that when I multiply it by 18 is going to give me 288. So what's the opposite of multiplying by 18? Dividing by 18. So I'm going to keep my 288 in there. Notice I kept it in there. And divide by 18. Okay, that gives me 16 sheets. Divided by 18 equals 16 sheets. Okay, I'm not done yet, right? But now I know how many sheets I need to put in the oven because they gave us this important rate over here. They said that you can make 8 sheets in 2 hours. So 8 sheets in 2 hours. And how many sheets are we making? We know we need to make 16 of them. And how long is that going to take? Well, some of you might be saying these are just equivalent fractions. We know how to do this. 8 times 2 is 16. 2, what am I going to multiply by here? I did 8 times 2 is 16, so I got to multiply by 2 here. 2 times 2 is 4. So 4 hours. So can I stop at 4 hours? Can I say I'm done? I hope you're not saying we're done because we started at what time? 4 p.m. So if we started at 4 p.m. and we add 4 hours to our time, where are we going to end up? 5, 6, 7, 8. So 8 p.m. is where we're ending. All right, so I hope you're able to follow along with our review of unit rate, COP, tables, equations, maybe writing it in words. There is a little bit of practice to try, and make sure you watch my answer key because it has some of the information you need to finish it.